Hey everybody, so we're going to continue with the videos going into Unity and working on our physics game, our Breakout game. But first of all, I want to recommend you look on this video, and I'm going to work with some concepts that are explained in this video to show you what we're going to do in order to control velocity in our Breakout game, in our popcorn game. So just by the first look on this video, you can see that there's input to vector, there's here a sum of two vectors, okay, and we see here gravity, okay, we've seen how gravity affects our object once it is active, and I do recommend watching this video to get a better comprehension of the way vector works, but we're going to have a small look on this in our Unity game and understand how we can use it later. Okay, but I really recommend looking at this video. Okay, this is a great solid project, great material, and I can explain it, but look at it from that point of view. I'll show you a bit in the Unity, in the code point of view. Okay, so let's get back to the Unity. So this video, just for a second, in order to find it, I looked for 2D vectors math explained, and I got to this introduction to vector for game creators, which alas, collabs with Pickup. I don't know, but great. Okay, so let's have a look on Unity itself. So this is what we have. Remember, when we press play, okay, let's let it start working. Okay, so when we press play, we have here, you know, the ball scripts and the next value, the next velocity, okay, which set the direction. So now we have 0.5 in the x, and as we said, I can do -1, press, I believe we did with spacebar, and it will start moving in the other direction. See it here, twice the speed, and we can add the y, and so on and so on. So I want to show you how vectors actually work. So vectors, as we've seen, we're giving it an x and y. It's like a point. But this point actually tells the ball where to go from. So if the ball is, let's place it on 0, 0, 0 and 0 on the x and the y. So now it is exactly in the middle of the screen. Okay, exactly where the camera is, exactly in the middle of the screen, and we would use that. So now let me show you something interesting. If I right click here, and I'll do create an empty, and I'll call it ball target. Okay, and this is a very simple object, and currently it's in some position, and we can add a sprite for us to be able to look at it, but we can do something else. So one of the things you can do is select here and select some kind of point here, so it's not really shown on the game, but we can see it here. But you know what, actually a sprite might be better, so let's do it. So what I'll do, I'll actually right click here, do 2D object, sprite, let's go for triangle. Okay, so here we have triangle, which change the color to red, and we'll make it a bit smaller. So I can select the scale here, okay, the scale tool, or I can use, I think, R, okay, and just press this and make it smaller. Now, remember that when we use the ball, we press the spacebar, it uses the next velocity as the point to go to, right? So let's try something a bit different. Okay, so instead of getting this value, I want to get the value of this target. How would we do that? So let's go to the code, and we want to have access to the target, the ball target. So the ball target, it has no code. It is just a Unity object, and we can use it. So the basic object in Unity, you can think of it as either mono behavior, or you can also use the game object. Let's do that. So I just put here public game object, and I'll call it ball target. And I'm not putting any value because I'm going to put it from Unity. And now, instead of going for velocity using next velocity, I will actually use this one. Okay, so let's see how it can be done. So we know that the next val is vector 2. Okay, vector 2D. So we cannot take a vector 2D or create a vector 2D from the ball target. How would we do that? So let's say something like this. So we need a vector 2. Okay, so it's a ball. Let's call it ball target. Oh, okay, let's call it vel2 ball target. Okay, it's a bit of a strange name, but the idea is that this is the velocity that is based on the ball target, moving to the ball target. Okay, and this one will be equal to a ball target dot transform dot position. The position has an x and y, and we are going to just take it from there. Okay, now this may cause us a problem, right? Because this is vector 2, but if you remember, the position is actually vector 3. You can see it here. And this is vector 2. But the thing is that the C# code, the Unity, it's know how to... One sec. Okay, so again, this will work because all we need to create a vector 2 is just take the x and the y from the vector 3. And it knows how to do that automatically. So we have a vector 2 which can be used as velocity. So let me just take it and put it instead of the next value. Okay, this is nice. But I want to do another thing. Okay, and what I want to do is, in order to, you know how we change the velocity, we change the next velocity, and because the ball moved by the last velocity outside the screen, it was hard, you know, to see it. So let's change that. Let's change that by just taking the transform dot position. Okay, so we start with transform dot position, right? And we will change it, and this is also a vector, right? We said it's a vector 3. The same way the ball target transform dot position is a vector 3. This one is for this object, the ball. So we want to take the ball and put it right back 0, 0. So we will always see it in the middle of the screen when it starts moving, and we can see where it's going. So let's change the transform position and change it to 0, 0. So it's actually there is a really nice shortcut for it. We can just take vector 3.0, and it will return us a vector 3 with all the values in 0. So we take in the position and put it back to 0. We take for the velocity the position of the ball target. And so the ball should always move to that target. Let's have a look. So I'm going back to Unity. And let me see, no error. Okay, so I'm going back to Unity. So now, even though we still have the next val here, okay, and it works by the next val, let's begin with it. When we press 0, so spacebar, it's going to go back to 0 and move to the ball target. The thing is, if you look here, ball target is still none. We haven't placed here anything. So we know that, for example, when we worked on the pad, we put variables, right, on the pad script, and we place the values here. But what about if we want to put an actual object as a value for our variable? How would we do that? So let's go back to the ball, and the ball needs to know where the ball target. So all we have to do is actually just take the ball target. Okay. By the way, let's make sure that the triangle in 0, 0, 0. Okay. And let's take the ball target, take the ball, and just drag it inside here. Okay. And you can see that it has a small plus sign because it can add it inside and actually set the ball target to be the object we place it. So let me just put it here. It's nice even show this small sign. And I'll change the first velocity to 0. And let me just run it. This should work now. So now if I press space, it moves to the target. If I press it again, move it back to 0, 0 and moves to the target. Again, very nice. Now, while it's working, I can take this, I can use W to move the ball target and move it here. And now if I press the spacebar right here, okay, the ball returns here, and look, it moved directly to the ball target. We just took the position of the target, we defined it as the velocity, and it moves to that position. This is great, right? Okay, let's do it again, and let's move it again. to somewhere else. And again, we press the space, so we do it here, okay, and the ball moves to that direction. Now, this is really, really nice, but what about something else? So this one thing works, if you notice, because the ball is always placed back in the middle, okay, it's always been placed back in the middle of the screen, okay, but you know what, okay, so this is actually vector calculation, because what really happens when we said that we use the x and the y, the position of the ball target, what we actually set we set it from this point, the 0, 0, to here. So it wouldn't work if the ball wouldn't go back to 0, 0. What do I mean by that? Let me go back to the code. Okay, and sorry. Let me go back to the code and change it. Instead of 0, 0, I'll put it in comment now. Let me just put it in a new, okay, new vector 2 or vector 3, and I'll just put 0, but 1.5 and 0. Okay, so this will be above the 0, 0 point. And this will affect the whole work of the velocity in a very different way, and I'll show you how. So we go back to Unity. This is one of the things I love about Unity, because it gives us the opportunity, when we work with Unity or developing a game, it gives us the opportunity to actually see things like physics and math and other principles of computing, and see it on the screen and change it and play with it. So this is a great tool. So now, when I press play, and you see here the target, okay, look what happened. When I press the space, it goes up here and go to that direction. Really strange, right? Okay, why is it going to that direction, not the triangle? Very simple, because it's no longer on the 0, 0. Okay, so it go on the direction from 0, 0. Okay, and you know what? Let me help you with that. Let's just create a 2D object, another one. We'll use square. Okay, and we put it as green. And I'll just place it on 0, 0. And we'll make it smaller. So again, using the R here. And making it smaller. Okay, like this. So I do that just so you will be able to look on the direction between the 0, 0 and the triangle, the ball target. And if now we run the program, and I press space, look what's going on. It's going in the angle from 0, 0 to the triangle, to the ball target, but it's going from the place we told it to be. Okay, and the place is up here. It's a 1.5 up, right? Now, what do we need to do to make sure this ball going in the direction of the ball target anywhere on the screen? Okay, so how are we going to make the ball move from anywhere on the screen to the ball target? So if, just for now, I place the ball in the position I told it to be. Okay, so I put in 0, 1.5. Okay, I actually did it to the square. Okay, our target. So I'll just Control Z. I'll go for the ball and do the same thing. So 0, 1.5. Okay, so we know that if it would be in here in the 0, 0 point, it would go directly to the target. We've seen it work. So when we do the calculation, we kind of need to do this change through code while doing it. So what do I mean by that? So if the ball is here, okay, and we want to move it from this position to this position, then we actually need to take the difference between the target position, which is the ball target, to the ball. So it's basically just subtracting the x and the y from the target here to the x and the y of the ball of the position. And this is true because when the ball was on 0, 0, Okay, it works because that's what it does when it takes the x and y. It's the same as if the ball is in 0, 0. And because we move the ball, we need to take the x and the y, but minus the x and the y of the ball. So I know it might be a bit confusing. You can relook in this video, see the other video and think about it, but let's just see it work for now. Okay, so how will we do that? We go to the code, and we have the transform.position for the ball, right? And we change it, but we don't want change. We do want to do another thing. Okay, so we basically want stuff like that. Vector. We actually have this position. So let me do another one. Okay, let's do that list. So velocity to ball target. This is the position, and let's just subtract. Okay, the transform dot position of the ball. Okay, so basically what we're doing like this. We create new vector. Okay, vector 2 that gets for an x the target x minus ball x, and for the y the target y minus the ball y. So this is like a short explanation of what's really done here, because this is calculation in vector and this is how it actually been done. We take the target x, we subtract the ball, the origin x, we do the same for the y, and we get the vector in the right direction and in the right length to go from the ball position to the target. Okay, so now we don't even change the target of, we don't even change the position of the ball before moving it, we're just using it so the ball will move from that position to the target. Okay, so we do the calculation here, we place it here on the rigid body velocity of the ball, and this should work. Let's have a look. We go back to Unity, and we play the game. Okay, so now if I just press the space here, it goes into this line. And if I press it again, it goes back. Again, and again, this is really nice. Now look, if I just, okay, now see something interesting. Okay, I got it here. So if I take it here for a second, again I place here the spacebar, it will still go in the direction because it always knows where the ball is staying. Now even if I take the ball target and start moving it around, no problem. As I press the space here, it goes here. Okay, so this video is quite long, but I want to show you how we can make it even more interesting. I didn't plan to do it this way, but let me show you how we can use and control the mouse. Now this is a bit more complicated. So what I really want to do is get the mouse position. Okay, so how would we do that? So in order to get the mouse position, I'll need to do it by mouse click. So instead of doing the space, I'll put this one in comment for now, control slash. It doesn't work here, so never mind. I'll do it like this. So I'm commenting out this code, and let's work with mouse. So for mouse, we actually need to check if the mouse was pressed. So if input dot mouse. Can you see we have the mouse position? I'm going to use it very soon. Get mouse button down, and it wants to know which mouse button, and we use just 0. Okay, so this is the left click of the mouse. So if we get a mouse button down, we need to calculate where this point on the screen. Now I'm going to move fast with it. I'm not going to explain all of it because this is a bit more complex, and we'll probably talk about maybe in a later video. But for now, I'm just going to get the mouse position and understand where it is on the world, which is more important. So what I'm going to do is the camera dot main, which is the main camera, and it's going to be get I need to recall how it's been done. So let's go for it. Google and just search for Unity, get mouse position. This will probably work in world. Okay, how to convert the mouse position to world space in Unity. There are videos about it, and this is what we're looking for. So, instead of 2D and 3D, I'm just looking for the specific code. Okay, so here we go. I'll just copy it. And we go here. So, vector 3, world position. So again, camera main, screen to world point. Okay, and it uses the input mouse position. And this will actually give us the vector on the world. And this is the vector we want. And now we can do it like this. So we can, first of all, let's change the position of the target so it'll be easy to see. So target, so ball target dot transform dot position will be equal to this world position. Now once we change the position, everything else can work just the same. Okay, so we can just take this, put it here. So we again calculate the vector from the ball to the target, and we make the ball go there by changing the velocity to go there. The only thing we change now, because we're using the mouse, it will be very easy. We just press the mouse and we change everything. We change the position of the target and we start the movement in the same step. Okay, so we're back in Unity. Everything looks the same, but it's not. Now when I press the mouse, you see it moving here. It's funny, it's the pad, right? Every time I press, it moves there, but we don't see the target. I'll fix that. It's probably just, you know, the Z coordinate. So let me just place it. Okay, so we have a vector that, and we put the world position, but let me do it in a bit of a different way. New vector 2, vector 3, and we'll take everything. We'll take the X, and we take the Y, but not the Z. The Z I'll leave in 0, which I think will make it visible. If not, we'll solve it. So let me go back to the Unity. And let me run it again. And I think it works. Let's have a look. Yeah. Okay, so now every time I press, the ball moves to the target. The target is changed to the position where the mouse is clicked. So we can see it. And the ball keeps moving to that direction. And we can make it go to the pad every time. Okay, or move to the center. Now, just one last thing about vectors. You see that if I press it far, it moves fast. If I press it close, it becomes slow, because vector is not only the direction, it's also the force. And the force is how long the vector is. So if I press it close to it, then it's very short, so the force that is being activated, the velocity that's set for the rigid body, it's very small. It's what is called has a small magnitude. Okay, but if I put it very far, it's very fast. So for now, I just let it move up and up, the ball. Okay, if I look in the ball here, you can see it moving up and up. But if I go here now and I press here, you see, it went back with so much energy. Okay, let me do it again. Okay, and coming. Okay, but it's too fast to control now. Physics problems. Okay, so I hope you enjoyed this video. This is a complex matter, but it's very, very powerful. Once you understand how to work with vector in Unity, this is a whole different game. You can make all kinds of different physics games, and I love it. This is why one of the reasons I started to create games, and I was so happy to get into, first it was Game Maker and then Unity, because it actually gave me the opportunity to work with a physics engine, okay, without having to know how to do all this calculation myself. But you still need to understand how vector works to make things work. So I hope you enjoyed this this video. I usually don't say it that much, but please, if you can, like, subscribe, put a comment, and I'll see you in the next video. Thank you very much.